Hi guys, today I'll show you how to show the internal representation of data in byte ordering. So let's start. And first I have a sample text file here called sample.txt, and if you look at the contents, it has a name of a man called Griff and the year of the date this man is born. And let's read the line first. So you can declare a file pointer write the name of the file and read in the line. S and you gotta declare variable to store the two strings. Let's call it name and year. And let's print out the data. You gotta compile and execute, and you can see the data read in from the file. And we are gonna look at how this string is represented in the memory and see how this data type int is stored in the memory, and they are stored in different orders according to which operating system you are using. So let's go to print out the bytes from for the data name first. Void show bytes, and you gotta specify the size of the string up to which you want to print. Until it's less than size, and increase the index. And cause we wanna print it in a hexadecimal, and if one character is less, cause we want to fill in with two hexadecimal numbers, we gotta write the directive as %.2x, and you gotta store, cause you want to print from the address, start of the address, the data is stored in the memory. You gotta declare a pointer that stores the address of data, and let's print out the byte from the start of the address data. And let's call show bytes and pass in the argument name, and we'll use strlen to get the length of the characters. And to use strlen, we should have standard string the header. Let's try again and see the result. See, you can see 63, 72, 75, 79, 66, 66. This 63 matches C in ASCII character, and R equals 72 in ASCII table. And let's see if that's true. You can search ASCII table and find C. Here it's represented 63, and you see 63 equals C, and 72 equals R. R is here 72, and let's just see one more character, U equals 75. U equals 75. So now you can know that the data that's stored in the memory are represented in hexadecimal, which matches the ASCII character of the data. So let's print out the int, and cause int is 4 bytes, we have the size for int as 4, and let's declare the function name as show int bytes. Stop p, and actually we gotta declare the type as int because we are passing int type, and you gotta convert the type to unsigned char to point to the start of the address of data, and print out the bytes starting from the start of the data address until it reaches size, and then increase index, and printf, and in the same format as before for printing out the bytes. And dereference, and let's see how int is represented internally in the memory. Pass in year and size of int, and we'll have space to distinguish between the name and the year. Int bytes semicolon. Where did I get the error? Oh yeah, I omitted a semicolon here. And try again. Yeah. Actually, cause this is char and this is int. We gotta do type conversion from char to int year, and typecast it to using ATOI. This is in standard library.header, so we should include another directive And let's try again. And you pass in the address of the int year at which this data is stored in the memory. Compile and see the result. Something's going wrong here. This is not data. We should point to the address of the data, so we gotta put in pointer which has the address of data and see the result again. Here you see 9B070000, and this data, this representation, this bit representation matches 1947, and because the operating system this program is running on is Linux A664, it uses Little-endian for its byte ordering, so the data is represented from low order bytes. So if it is represented in Big-endian, it should be 0000 and then 07 and then 9B and C. Let's see the value by calculating it. And here I assume you already know how to transfer from byte from hexadecimal to decimal, and it's B, so it's 11, and then addition 9 times 16, and then plus 7 times 16 to the 2. Let's see, this number is 1947, which equals the data we read in. So that's it for today, and thanks for listening to my video.